Welcome back to the Hydrogen Fuel Cells Europe on Tuesday afternoon in the public forum here at the Hannovermesse 2022. My name is Muriel Burkas and I will hosting the next interview. What are we talking about? We will talk about enabling global hydrogen fuel chains, connecting supply and demand with LOHC. Please join us, have a seat, enjoy some refreshments, enjoy the talk. And now a warm applause for my guest, Rafael Schmidt, Head of Business Development from Hydrogenious. Rafael, thanks for being here and taking the time.
Thank you.
Maybe before we go into the technology LOHC, I'm sure everybody is wondering what does it mean exactly. Let's take a step back and talk about the starting point. Where are we? Why is it important to talk about LOHC? Can you set the stage at the beginning?
Yeah. Thank you very much also for the invitation and for the opportunity. And I mean, we all know what kind of challenges we are facing right now in this world. So it's due to climate change, it's due to political tensions we feel, energy dependency on different countries. So it all comes down to reanalyzing and reshaping the world of tomorrow in terms of energy. And LOHC plays a major role, as we see it, as transport vector. So enabling transport from different countries inwards to Europe, a transport of hydrogen.
Okay, so to make sure that we have enough carbon neutral energy in Europe, you provide a solution and it's called LOHC technology. So maybe you can talk a bit, what is it exactly, LOHC?
Yeah, very much I would like so. So LOHC is basically a technology we developed as a company in Erlangen. We're a spin-off of the University of Nuremberg-Erlangen, German company, 150, 160 employees. And LOHC is basically a technology where hydrogen is being attached to a carrier molecule. So the idea behind it is, and that was also the initiative, how to make handling and transport and storage of hydrogen easier, because it's a very small molecule. So therefore, very difficult to handle, very light. You have to compress it with high pressures, or you have to cool it down to very low temperatures to be able to transport it. And so the idea is using other molecules, attaching hydrogen to other molecules which are already carbon-hydrogen molecules. Then afterwards, and before, the carrier molecule is before and afterwards liquid. It's an oil, a heat transfer oil. And it's just being attached with additional hydrogen. It's a chemical connection, so perfectly stable. And the carrier is before and after being loaded with hydrogen, hardly flammable, non-explosive, non-toxic, can be transported and stored at ambient conditions. So it's perfectly easy to handle and transport it.
So it's a way to solve the hydrogen storage challenge that is going on, to work with thermal oil and to change how we transport hydrogen, right?
Exactly, and
okay.
It's basically, just to add that, it basically comes down to the one point where hydrogen is being attached to the molecule and to the other point where it's being released. And this is the centerpiece of technology, and everything which is in between is normal fuel logistics. Basically, the tanks which are already there for diesel, oil, gasoline, trucks, trains, ships, so we can leverage on the existing infrastructure.
Also sustainable to not change everything, but be like, oh, it's already here. Let's use it for the better. How is the development at the moment going on? What are the dynamics that you see in the market?
It's a very good question. If you look at the hydrogen market, at least from my perspective, it all started with how do we produce hydrogen and where do we use it? So it was all around electrolyzers and around fuel cells. Also mobility was a very strong focus, but now we see a change. Now we change towards really decarbonization of the industry. So volumes become larger, people are thinking about, can we produce all that here in Central Europe, or do we need to, or Central Japan also, or do we need to get it from somewhere else? So transportation becomes a big topic. And companies, larger energy companies, are very much now looking into how can they solve that? How can they provide the hydrogen needed by the industry to decarbonize on this very large scale.
I think especially when we talk about timing, right? When it needs to be here tomorrow, basically, and we don't have the time to build everything by our own in Europe, for example. Okay, so it sounds like a great technology, sounds like a good solution. How is it? Is it like unique what you're doing? You come from, it's a spin-off from a university, it's a new technology. Can you talk about how many organizations, companies are doing this, what you're doing?
That's again a good question, because at the end there are only a handful of companies, or actually two really commercial companies in the world doing that. And it's basically a company from Japan called Chiyoda, and it's Hydrogenious from Germany. So it is a very unique technology, you could say, only being provided by a few companies, which is a challenge for us as a company, but of course also an opportunity for us being a company. And we're also heavily working on it to spread the word, to support research on the technology at different universities. There's so many universities doing research on it. There is new clusters being built up based on LOHC also. And there are a lot of companies coming up targeting also this technology and trying to develop their own style and own basic technology.
So right now there's a lot of dynamic going on in the market of hydrogen. Maybe can you talk about your projects? Where is it heading? What are the next big things? I've read some stuff online, but I think it's easier if you explain it.
Sure. Well, it's how you always start. I mean, you start with something small. So you start in the lab, then you try to go out of the lab, do pilots in the field, and we did a lot of pilots in the field in Finland, in the US, in Germany. We have a cooperation with H2 Mobility on a hydrogen refuel station. So it's all very, very helpful and very good insights, but now it comes down to being commercial. And I think that's the challenge we all have in hydrogen, doing something commercial. Scale it up, try to get rid of funding, things like this. And the first commercial project we're developing right now, and we are in the permitting process and shortly for construction, is in Dormagen, together with Covestro and our investor Vopak. A counterpart will be, there is a hydrogen source in Dormagen, and a counterpart will be in Rotterdam. It's green hydrogen based, and it's 5 tons per day of volume. So it's already a little bit bigger. And then we go beyond that with our IPCEI projects, for example. IPCEI is a funding scheme here in Europe being implemented to kickstart the hydrogen economy, and we have 2 projects in it. And these are then larger projects, already including ship transport. So from Spain to Rotterdam, larger ships carrying LOHC and then carrying hydrogen also. And then the next step is already being prepared in terms of announcements we did with ADNOC, Abu Dhabi National Oil Company, because we see a lot of drive in the Arabian world. And they want to participate. I mean, they see how the business models are changing and how the future will look like. And so their basic question is, how do I participate in it? And they see all this hydrogen demand by the industry in Central Europe, in Asia. And they say, well, we want to participate by it, and we can produce hydrogen, but how do we get it there to be able to participate really at the market? So that's the next step, and that's where we also in a feasibility study right now, and where we're planning to implement even larger pilots, and then heading towards 100 to 500 tons per day to match our technology in size with one of our competing technologies, ammonia.
Okay, so many projects ahead. Maybe quickly about the Abu Dhabi collaboration or partnership. So the idea is that hydrogen is going to Abu Dhabi, or that Abu Dhabi is bringing hydrogen to Europe? Which way? Both ways?
Most of all, it's from Abu Dhabi to Europe or to Asia. So the idea is what kind of regions are most suited for hydrogen production, and where do you need all the hydrogen? So what are the demand centers? And we see that the Arabian world has great potential for PV, great solar potential, and therefore hydrogen production is a big topic. And they are already used to handle energy. And they have also the resources. They have the knowledge, they have the money to do so, they have the political willingness, they thought it through, so they're quite far. There are other regions which are also very beneficial for producing hydrogen and renewables. But these are not so far in terms of real project development right now.
Okay, so it's just changing from oil to hydrogen, coming to Europe from the Arabian world. Great. Then you also talked about storaging 5 tons of hydrogen a day. Maybe to give the audience a little bit of a perspective, what can I do with 5 tons of hydrogen a day? How much households can I cover, or cars I can fill?
Yeah, I mean, we did the calculations. Normally that's the specific thing about the hydrogen sector, I would say. We think about kilograms and tons per day or per hour, and it's very hard to grab. So I like the question. It's basically, if you would transfer it, and I mean, of course, you have to do some assumptions, but it's basically 8,000 to 10,000 households that could be heated with this 5 tons per day hydrogen volume, or it's roughly 200 buses a day that can be fueled, or trucks with this hydrogen. So just to give you a feeling, something around that.
Okay, so like a small city can live with 5 tons of hydrogen at the next project coming up. Okay, so I quickly would like to open up the question round. Are there any questions from the audience? Yes.
Hello. So I have 2 questions. First is like, how much hydrogen can you carry in a normal trailer, like on a road, with LOHC? And the second would be, what's the cost comparison with ammonia? Because you mentioned it's your biggest competitor. So what's the deal?
Okay. Yes. The normal questions, I would say. It's basically you can carry up to 1,800 to 2,000 kilograms in one trailer. So if you're talking about the normal fuel trailer, 30 cubic meters being transported, roughly around 28 tons of cargo load. If you go to trains, of course, it's also possible with our technology without any problem. You expand the volume, and if you go to ships, you expand it even more. So the amount of hydrogen being transported on larger ships is significant also with LOHC. In terms of, what was the second question? Costs. Yeah, costs. Yeah, it's a good point. It's also something where we turn our heads as a company around, because it's around, if you develop a technology, it's around where's it best suited and where do you focus your energy on in terms of manpower and all that. And we did analysis internally, we benchmarked it externally, we had a study with Roland Berger together, strategic consultants. We also benchmarked it with various TCO studies you have already on the market. You have by the International Energy Agency, by the Hydrogen Council. I mean, there are a lot of transport studies already out there. Also Roland Berger published theirs. And we see, I mean, they all show that LOHC is a little bit, has less cost than the other technologies. But I would say, looking at these generic TCO calculations, you can't tell by the 0.1 cents per or euros per kilogram. It's not a difference you can rate. So I would say it's cost comparable. We have the same costs in these larger scenarios than the other carriers, but we think that we have the better characteristics in terms of easiness of handling. You don't have to pressurize it, you don't have to cool it, things like this. It's non-toxic. So the handling and the characteristics are better, and the costs are comparable to the other technologies.
Thank you very much for these questions. Are there any other questions at the moment? Yes.
How easy is it to scale up the carrier liquid, LOHC? Is it a byproduct of other chemical processes, or does it have to be specifically produced for your application? And if so, how easy is it? And also in terms of costs, how easy is it to scale it up for mass usage?
We're talking about scale up of technology and of the production of the carrier liquid? Okay, yeah. It's also a good point. I mean, that was one of the major points why we choose that liquid we're using right now, that it's a product which is on the market available. So we don't have to reinvent it and produce it ourselves. It's actually Eastman and Arkema producing already that liquid for the heat transfer oil market. So it's something we can buy from them. But basically, the heat transfer market, I mean, as soon as we go into larger transports of hydrogen, we outrun the heat transfer market in terms of volume. So we are closely cooperating with them and picking them up in terms of our project development and their capacity ramp up. And of course, we are also looking for diversification of suppliers. We don't want to be reluctant on one supplier or two suppliers. And we are also looking, because it's the carrier liquid is toluene-based, so it's fossil fuel-based. I mean, we can use it several times. It's like a liquid battery, you could say. You can charge it and discharge it over 300 to 700 times. But it's fossil-based still. I mean, you can use it a lot, but it's still fossil-based. And so the idea goes also, we have research programs going beyond that and analyzing how can we synthetically, out of carbon and hydrogen, compose a carrier liquid which has similar characteristics as the one we are using. So that's future development.
Good. Then I would like to continue with another question, and I'm going to head over to you. We talked about that it's easy to storage, or we can use the existing infrastructure that is here. So why are we not just doing it or building the storage space and work with it? Because it sounds like a great solution. What are the challenges, or what is holding back?
Yeah, it's also a good point, and I mean, it goes in the same direction with expansion of production of the carrier liquid. Also, the question is, how do we scale up the technology really doing the process? And we as a company, we try to be realistic. I mean, we're Germans, we're German engineers, so we are very realistic in what we are saying and time perspective and things like this. And also very open, because we are one of the few companies providing the solution, so it's all about transparency also. And the challenge is really meeting the right scale-up steps. So you can't go directly to 100, 500 tons per day on projects which are then €1 billion of investment volume, because if that project doesn't work, you have a very big problem. So it's about feasibly sourcing the scaling steps that bring you sufficient technology insights and also are handleable, manageable in terms of investment and financing. And therefore, we need one or two steps in between. So I talked about the 5 tons per day step, and then we have the 25 tons per day step as the next step. And then we have sufficient information and data to scale to, let's say, world scale. Ammonia says business class size, which is then 100 to 500 tons per day of production, which is really the future case we're facing.
Okay, step by step, I would say. Okay, I would like to give you the last questions.
Thanks for the insightful discussion. Just curious to know, as a hydrogen distribution company, are you now more centric only to transporting green hydrogen molecules, or are you also partnering with blue and gray hydrogen producers per se as of now? That will be my first question. And the second is, what are the challenges you see in more achieving 100% separation efficiency for retrieving all the hydrogen that is co-transported with the Cara liquid? Do you see any product loss at the stations where you transport to, or like is it 100% separation efficiency that you achieve?
Yeah. Okay. Well, starting with your last question, in terms of do you have any losses in the process? And basically, we don't. So it's a chemical process. It's taking place in a reactor. You inject hydrogen, you inject the carrier liquid, you have a catalyst, and hydrogen going in the reactor is completely reacting with the carrier liquid. So you don't have any loss of hydrogen, and if there is hydrogen going out of the reactor, you just recycle it, and therefore you ensure that all the hydrogen being produced is also used for binding it to the carrier liquid. And then on the release process, it's similar. We have very high purities on the release process, so we normally, if you go to pipelines or industrial users, we don't need purification, and purification would be the step where we would lose hydrogen. Because if you use a PSA unit, part of the volume stream is being lost. So in that case, yeah, I would say there is some particle loss, but most of the cases we won't need to purify it. Okay, and then coming back to the first question, what was it? Color, yeah. We see the molecule. So for our process, it's relevant that it's hydrogen. What kind of color the hydrogen has is for the technology irrelevant. But then the question comes down to political context, the question comes down to project development and project lifetimes. So how will the future of the hydrogen economy look like? Will we have, if we now have a project development of 3 or 4 years, and then we have a lifetime of the project of 10 to 20 years because of infrastructure, will we in 24 to 25 years still use blue hydrogen, or will it be purely clean? So it's more like a strategic thing of how to orientate. And I would say for this larger long-term projects, I would rather go with green hydrogen because we see it more substantial, more future-oriented than blue hydrogen, which is in our point of view, but it's just our business point of view, company point of view, just like an intermediate solution. Because you have steam reformers already on site, you just need to add CO2 capture, then you have blue hydrogen, so you don't need to install and invest a lot of capex to be able to already provide blue hydrogen to the market. So it's more like similar than I see ammonia. Ammonia is also for us. It is very logic that a lot of companies are going with ammonia right now because it's already existing infrastructure which can be used. And very, very little investment to be done. And an existing market in terms of fertilizer and dynamite and whatever else ammonia is being used. So it's already an existing market, so it's very easy to enter that and very low risk for larger companies to do so. But then ammonia has their limits in terms of when you want to go beyond that fuel market or feedstock market, if you want to address the real hydrogen market, then ammonia becomes difficult in terms of cracking, and then we see the feasible application of LOHC, which then has the better characteristics. But I'm not angry if anyone says that he wants to go with ammonia right now. It's basically a matter also of timing, a matter of how do you see the future, and a matter of also leveraging on all the opportunities we have to provide that amount of hydrogen we need. Sorry.
Thank you, no worries. I see we could go on, but unfortunately we're running out of time. So thank you so much, Rafael Schmidt, for being here from Hydrogenious. If you want to talk about it further, I see there is still so much interest going on. He's going to be here all week. There is the booth number C33 if you want to talk about it, or right after the talk now. Thank you so much for being here, Rafael Schmidt.
Thank you.